What's up, everybody? Welcome back. Today we are working on trying to get uart support on our Zig build running on a Raspberry Pi Pico. This is part of a larger project of trying to reverse engineer the firmware on my Xbox controller. So context here is that this guy, he's got a couple paddles on the back. Paddles, pretty good. That way when I'm playing shooters on a controller, like the degenerate that I am, I can keep my fingers on the stickies a little bit more. Like my thumbs stay on the sticks, I get the little paddles on the back with just extra button presses. Big win for me. But paddles on the back, they are kind of mapped in firmware on the controller, right? The idea here is that like you're gonna plug this controller into your Xbox, and your Xbox has like 5 buttons on it, right, or whatever, and the Xbox only knows how to interpret those buttons. So you in the controller firmware say left paddle map to A, right paddle map to B. And that's like good for that case, but I don't have an Xbox, I have a computer because something make me feel superior, PC master race or something. But I have a computer, and computers have lots of buttons. They can interpret tons of them. And so it would be nice to me if the paddles were like their own real paddle buttons, and I could configure them in Steam to do other things. Like maybe I want them to be my push to talk button, right? Maybe I want them to map to a keyboard key so that I can use them as like a Discord push to talk, right? Just whatever. I just want them to be like their own buttons. I completely forgot that the controller dump was the final goal. Yeah, it's because we're like 4 layers deep on side quests. It's whatever. So we have I took a look at the firmware dumps that I could get for this guy, and I didn't see anything very like useful in there, right? And so I'm like, okay, what's like the next entry point? I just pop the guy open. I'm like, maybe like we'll glean some information if we just like look at the board, right? And so this guy, he's probably like the system on chip CPU. But like this, I Google this chip name and I don't find anything interesting. I'll probably revisit this at some point, but I don't really know right now. This guy though, this guy has a name that we can Google, and it turns out that this thing is some like EEPROM, right? So it's like programmable memory. And my hope is, I'm like, programmable memory, we could look at that thing. Maybe there's something interesting on there. Probably not, but there might be, right? And so we're kind of on this like slow quest to write a tool that basically we take EEPROM, we connect it to Raspberry Pi Pico. So this is like I2C, the connection to the EEPROM. And then this guy has like uart output. And we just basically like copy paste all of the stuff on here onto this uart that goes to my computer, right? And then at this point, we'll be able to look at this thing. Maybe there's something useful on there. Maybe not. Maybe it's like configuration data. Maybe it's like a firmware dump. Who knows? Are you going to desolder the EEPROM? Yeah. And so today we are looking at this uart. So Raspberry Pi Pico, he has like an SDK that comes with him where we could have done this in like one day, but that's not the point, right? The point isn't actually about the controller. We just have to say that there's a story here, but we're just not really, in reality, we're just having fun, and we're trying to program this Pico using Zig, using our own like from scratch environment. So we've got something right now that we can build with Zig build. And we have a little blinky light example. He's running right now. If we can orient this thing so that you can see the fucking blinking light. Where the fuck is it? Oh, there it is. Blink, blink, blink. And so today's task is to go from there to something that we can printf on. Having fun is not allowed. I'm offended. Yeah. So we in happy hour today, we did a ton of reading, like an hour and a half of reading probably. And I think we understand what we're supposed to do. We have this like, some notes that we took. But we'll spare you guys the details of things that we don't need to do. And we'll say, this is the plan for today. We're gonna enable a clock source. That's stage 1, because the uart, in order to talk uart, it's kind of like hand wavy. You have like read and write lines, right? And these, you essentially just kind of wiggle the bits on this line, and like each time period is like 1 bit, right? So it would be 1, 2, 3, 4, 5, 6, 7. Maybe you have 2 ones at the end, 7, 8. right? This would be like one character here, right? And hand wavy, you kind of just like agree with the other side. You agree with like the yeah, you as like the UART transmitter agree with the UART receiver on the other side on the format, where you're going to be like, I'm going to send 8 bits in a row followed by like one marker bit, and we're going to talk at 1150 200 bits per second, right? You just agree on that up front, and then you guys agree, you can read the data, right? So here we need to enable a clock source so that we can talk at like a fast baud rate, right? Where you have to say, we're going to be wiggling this wire at this speed. That speed needs to come from somewhere. So we need to enable a clock that has an accurate, that is like accurate and we can measure from. Then we're going to have to like connect it to the UART machine. Then we're going to try to do some sort of synchronous UART output, which should be relatively straightforward, I hope, but we'll see. And then there's kind of like a FIFO-based interrupt-based version of this thing, which if we get through all of this fast enough, we'll move on to this. But if we take too long, then we just won't do this part, because it's not really important, but working with the interrupts might be interesting, so we'll see. All right. Let's run it. I wouldn't say agree because that implies negotiation. I think assume is better. Yeah, assume is probably better. I agree. I swear, this is the very first time hearing that you say you read a lot, because you don't like reading because it's for nerds. Yeah, true. Because you would lose track of time while doing it. No. I always say reading is for nerds, and more importantly, I can't focus very well. I'm bad at reading, but this time it was necessary, so we had to bite the bullet. I find that like knowledge solidifies better by doing, is kind of my general thought, and so yeah, no escape from reading the datasheets embedded. Exactly. Okay, enable the X oscillator. So what is X oscillator? What are we fucking talking about? So my very naive understanding is that Raspberry Pi, he's kind of sitting over here, Raspberry Pi, right? He's connected to some rock, a little gray rock, right? And this thing's like got like probably like 2 lines coming in. You zap the fucking rock with some electricity, and it just kind of like vibrates a little bit, right? He like, you zap him with some electricity, and like this line comes out like this. People call these things crystals, but this is my understanding. Right? You zap it with the rock shakes. This thing gets connected to X oscillator input, right? So the Raspberry Pi has like an internal clock that it uses on boot. But then you start shooting this rock, and then you turn on the X oscillator. This guy has to like wait for some amount of time for this signal to become stable. But then once it's stable, it's like really stable. Poor rock. Yeah, well, I mean, sometimes you just gotta electrocute things to get them to do what you want. You know, it is what it is. So that's what I believe we're doing here, is we need to turn this thing on. The SDK would have done that for us, but we're not going to. No kink shaming. Yeah. All rocks are into BDSM. They all like it. Yeah. So I think it's something along the lines. I think we wrote down our notes here. Maybe we got to turn it on, wait for him to be stable, then set as a clock source for the UART clock. So I think turning it on, I wonder, we might have to take it out of reset. Let's look at like the reset register, the general reset. General reset. So when you boot the board, most of the chips are off, and you usually have to turn them on. Do I see anything about like X oscillator in here? No. So maybe it's on by default. PLLs, which are clock related, are not on. But it doesn't seem like there's a specific X oscillator enable pin, so I would assume that it's on. We can confirm that pretty easily by looking at his registers. So can we go back, X oscillator, and let's just try reading and writing to this guy and see if it makes sense. List of registers. So here we have X oscillator base. So let's make a little abstraction for this guy. X oscillator. We have some base register is this value. We have the status is base +4. And then we have control is base plus 0. I guess we probably want these to be, registers that we can poke at. So we're gonna cast these to volatile U32s. These guys are they're, how do I say this? They're memory mapped registers. So there's some piece of hardware that's sitting on some bus which is the same bus as like RAM, right? But it just knows that when I write to this specific address, RAM's like, no, that's not for me. And the X oscillator goes, oh, yo, that's for me. Okay, I'll respond. And all of our register writes have to be U32s. We're using volatile to tell the Zig compiler, like, hey, this isn't memory. Like, actually fucking read and write to this guy, please. Like, don't try to optimize that shit away. Don't reorder it. Like, this is like a thing that has side effects. And probably, I think that we need to set the startup delay as well. I think we saw that the startup, we want to set that to 1 millisecond, I think. I think that's what we saw. And then count, I think we might want to use count as just a test to make sure that this thing is working correctly. So we just want to like read this thing and seeing that it's continuously moving downwards at some like expectable interval, or like, that we if we were to read the count variable and like trigger some actions based off of it, we would maybe see something with a stable time difference, I guess. But yeah, we can start here. Okay, so control on power up, this is disabled. So let's just turn this fucker on. If the chip has been programmed to run from the X oscillator, then setting this field to disable may lock up the chip. Yep, true, but we're not in that case. Frequency range, we just have to set this to this guy. So this is bits 11 to 0. This is bits 20 through 3 to 12. So I guess maybe if we read this thing right now, we should hope to see 0xD1E on these bits. I think that's probably the first thing to check here. And if we see that expected value, then it's probably off. Because on power up, this is initialized disable. So let's try that. Let's just go here and we'll say X oscillator control. Can we just read this? Const X oscillator value is equal to this. And then, oh, oops, post in this. There we go. And then can we just comment this out? And then hopefully Zig won't optimize this away and we can just look at it in the debugger. That's kind of, ideal. I guess we probably need a programmer window open here. So we'll do that real quick. And we'll see where we end up. All right. So open OCD to program. Then we say run this shit. He's mad? Couldn't open? Oh, because I'm in the wrong folder. Let's try that again. Okay, and then actually, I wanted to do breakpoint here so that we can see what we got. Show me what you got. Nice. Okay. So can we print X oscillator control? Hype. Hype. Okay. D1E. That's D1E. So that's a really good sign. That means that, as far as I understand, that means that the chip is on right now. Like the register that we need to hit to enable this thing is not on, but the how do I say this? How do I say this? Fuck, my brain. Like, there's no, it's responding to requests. At the very least. So that's a good sign. And maybe sometimes it's good to just like fully double check by unplugging and replugging this thing so that like it fully clears its memory. And we just kind of print the same thing. Hype. Hype. Okay, so I think we're chilling. So in terms of like startup sequence, we were reading in happy hour that we need to set this startup register to 1 millisecond and then read the status register to see if it's running and stable, I think. So do we set up the startup delay first before it can be used? So I assume that we set this first, then turn it on, then read status stable. I assume, right? So we set the control enable register. This is not immediately usable because it takes time for the oscillations to build sufficient amplitude. This time will be dependent on the chosen crystal, blah, blah, blah. Yeah, I'm going to assume that that's the order. It doesn't really like explicitly say that, but I don't see what else it would be. Oh, here. They have some C code. Yeah, so they set the input value, set the startup delay, then turn it on, then wait. Cool. Cool. Simple. Simple, simple, simple. So we should be like, it's interesting to me that in their code here, they just raw write to the control register here. Because shouldn't the control register, we have these upper bits that we need to worry about, right? They're really only writing this, which is strange, unless their macro or their like enum here also has the disable like by default here. That would be strange, but it's possible. And then it's also possible that if you write zeros here, because they have like these like special things that they want you to write, it's possible that it just doesn't fucking care and just rejects them. So I'm kind of curious to see what happens if we do this, right? And you know, in reality, we should probably do like freak range, right? And here we have, I guess in reality we can say 150 freak. I guess you kind of want to like model the register as a whole. Maybe you want to go like right freak range. Maybe, yeah, I don't know. I don't really know how I want to structure this stuff yet. But it's fine. Maybe in here we do like init. That doesn't seem crazy. You do like x oscillator init, and then here we write like control is equal to 0xAO, and we'll say currently only valid value for frequency range input. And I guess we could say freak 1 15 megahertz is equal to. Fine. You know, we'll give them a name. We'll be good programmers. We'll be good. We'll be good. Are you sure that alignment is valid? What do you mean? And then here I want a breakpoint here and maybe like read the control register back. Arbitrary integer widths are so nice for doing register descriptions. No macro magic with shifts and masks. Yeah, pretty nice. Pretty nice. Okay, let's go here and we'll just call x oscillator in. Boom. He's mad because after's unused. True. Fuck you, Zig. Let me do my shit. And okay, so that's interesting. That's interesting. So we zeroed these things out, which seems like an invalid setting will enable the oscillator. Controls U32, but you're not writing U32? Well, we are writing U32. It's just not very big, yeah. Which is what they did in their example, which is why I wanted to try it. But we should just not fucking do that, right? So we should instead like I guess we can kind of do it all in one shot, right? So we could probably do like, we probably want to model the control register. right? And we probably want like, does it do low bits or high bits first? Probably high, right? Probably. So we want 24 to 32 is 8. And then you want enable, and can we say this is like enable enum, which is going to be backed by a U12, right? And this is like, we have two values here, disable or, yeah, disabled is D1E, and enabled is fab. And then we have freak range is freak range. And this is a U12 as well, yeah. And we have one valid value. I guess we do it this way so that we put the unit up front so we have a character. Okay. Cool. So now we should be able to write this guy. We should be able to be like, really, we can actually model this now as this, which is kind of hype. Does he read the chat? Yeah. It's just, sometimes it doesn't, if you're like, what is your typing speed? I read that and was like, I don't want to answer that right this second. I'm doing something. So, you guys can write what you want, and I can choose to ignore or even ban or answer. Those are all options for me, right? It turns out. Oh yeah, sorry, it makes sense. Oh no, you don't need to apologize. You don't need to apologize at all. It's just like I get to choose. There's like the reason I don't show chat on stream is because I like having control of what the VOD is, right? I'm like making a thing that people will watch, and so I want to be in control of what that thing is. So I'm not mad at you for asking about the typing speed. It's just like, what if someone writes penis? Well, if they did it a lot of times, I'd probably ban them. But typing speed is probably like 120, 100 to 120 words per minute, probably in that range. Since you asked so nicely, okay. I want to make sure that this value is the way I expect. So if we look at like control of reserved is equal to 0, is setting it to 0 wrong? It's almost like I should ignore it. But like, yeah, I guess you almost want like, you almost want to keep whatever bits are in the reserved section. So we almost want to do like get the control value. Yeah. So control val, I guess. Let's just start here and see what happens. We want to make sure that the alignment of like our packed struct and stuff is all right there. But can we print control val? Why? Why is that just giving me a number? That's annoying. He should give me like the full shebang. AA0? Damn. Also, we need to turn this thing off and print it back on so that the initial value is right. Okay. I guess then, can I like const control val, no symbol control? God damn, dude. Fine. We'll just write something then. control val dot enable is equal to enabled. And then we write it back. Oh, this is interesting. I guess we can just do this. And that should kind of just work. For some STM chips, right before a read is invalid. Oh, that's interesting. Holy shit, I missed a lot of messages. Modern ARM processors support a big Indian format known as BE8. This is only applied to data memory system. Fucking ARM. Do you know if there's an easy way to set up third-party apps to get installed to your HDD instead of your SSD? I don't know what you are asking, so I'm just gonna ignore that. Like, I don't even like on Windows. I don't know. Don't know. You should disable it though. Oh, that does 2 writes though. True. But I want to preserve, like, either I have to do a read and then a write or a double write. I think both of those. But yeah, I guess we could do, I wonder what happens if we do control is equal to, like, reserved equal to control dot reserved. And then, like, enable is equal to enabled. And then freq range is megahertz 115. I wonder if this is, like, legal. Really? Really? Got fucking compiled out. Can we then, I guess, do this? So this should be a U32. Yeah, so FAB A5. Is that right? FAB here. A5 not right. That's interesting. I wonder if I have this backwards, if it has to go the other way. Low bits to high bits. Yeah, there we go. Other way around. Other way around. Cool. Cool. You have the dereference, right? Did I not? I did. Well, there's a dot star here. Cool. Okay, so that handles that. But before we do that, we have to set the startup register to this stuff. So we have reserved. So we know it's low to high now. So we have delay, which is U14. We have reserved, which is 14 to 19. So that's 5 bytes, which makes this U19. No, this has to be U6 to make this U20, right? Yeah. It's inclusive. Confusing. Then this is X4. And then, can I do this? Is this allowed? Whatever the rest is. Can I do this? Is that legal? Duplicate number name? No. Can I like zig packed struct discard bits? You can have U14 and zig? Yeah, you can do any number. I want to like discard some amount. Do I have to write like reserved? Maybe zig lang reference. You can't discard, but it's because it's packed. Yeah, I guess that makes sense. But like, it seems like a thing that might happen, right? Where I'm like, just like shove in U14 worth of space. Like, it just seems like the type of thing that people would want. So it wouldn't shock me if it was supported. No padding between fields. Yeah, I guess not. Okay. Reserved, and we'll call this reserved 2. Gotta go think of the stream. No worries. Later. So this is now a startup like this, and then we're like startup equals, and then we kind of keep its reserved to its reserved here, and reserved 2 to reserved 2. Does it make sense to pad in like that? But I mean, clearly it does, right? Clearly in our world, we have like some bits that we want to keep and some bits that we want, like some bits that we want to modify and some bits that we don't, right? So I think it does make sense. It's just not something that they support, which I think is fine. Okay, so they want 1 millisecond, right? That's what they said somewhere. They said 1 millisecond is sufficient for the is a sufficient default. So what number do we put here? Nice. Then we can just write the answer. 47. Okay. So we're like x4 is 0 and delay is 47. And we'll say this is approximately 1 millisecond taken from 2.16.3 of RP 2040 data sheet. Yep. Chill. You can set default reserved equals 0. But what if it's not 0? Right? Isn't the point of reserved that in the future, a future version of this thing might have values in there that we like don't want to change? Then don't call it reserved. I mean, we don't know. Like for them, it's reserved. Like the whole, like it's a thing that they might use in the future, and so we shouldn't modify it. But then delete that default 0. But like we can just be correct for now. You can't write 3 bits. But I think that this is going to do what I expect. Strictly, you should read 0 the values you don't want to set with bitmax, then set the new value. I think that's what this is doing. I think. I could be wrong here, but this is what I would expect that to do. Shouldn't it be startup.star.reserved? It automatically dereferences if it needs to. Right, so I would assume that this does read value, mask out reserved bits, then set x4 and delay. That's what I would assume this does. I could be wrong there, but that's what I'm like. That's what I would hope. If you want that behavior to be explicit, yeah, that would be better, but I'm not gonna. Okay, so I guess now we need to wait for. Fine, I guess you're right. I guess. I mean, it would just be nice to check. Maybe Zig will do that for us. I'll just be eating popcorn for 9. Yeah, I guess it's fine. I'm just not going to worry about it. It's more like if I start doing this all over the place, then it'll be fucking annoying when I'm wrong later. So it's probably better to check. But also, I'm a lazy piece of shit. So, let's read status. Status. Okay. So we have freak range U1. We have, this is U2, and then a U10 of reserved. Then we have 1 bit of enabled, followed by 11 bits of reserved. I'll be back. Good luck. Later. Then we have 1 bit of bad write. And then 11 bits of reserved? No. What am I saying? 6 bits of reserved? And then 1 bit of stable? Is that right? This is add to 32. 12, 24, 8. Yeah, that's right. That's right. Oh, like you could really do something like this, right? You could do something where you take out all the unreserved pieces, and then you could do like write with params, write params, right? You could do it this way. Right? And then you could be like, then you could do like you could do like a read modify right here. Right? And then you could do like val freak range equals params freak range. Like you could do it like this. This is probably like technically more correct. You know, and then go like status equals val. But it's just annoying. But yeah, it probably is better. Oh, status here. He's mad because this isn't a status. And then here we're like, what do you mean there's no? Oh, yeah. So we'll get, say, fix me. Remove reserved here and here. We should do it the right way, but it's fine. Okay, freak range. So this is the same enum here, which means that this guy should be a freak range, and this guy is gross. He's like kind of the same value here, but here he gets 12 bits and here he gets 2, which kind of sucks, right? So we can't, it's like hard to reuse this guy, but we could do, it would be great to be able to reuse this. Oh, these are different fucking values. That's hype. That's so cool. That's so cool. Uh, enum, you too. So this is like, wait. I'm a dumbass. We don't write the status field, so we didn't have to do this at all. I'm just like I'm just fucking high. We should just do this. Finally here to watch live. Oh my god. Oh my god. Ambiguous reference. Yeah, that is fucking annoying. I guess we'll just put this here, and then it's not ambiguous anymore. These are like part of the control register. Okay. So we're not trying to write jack shit. We're just like, while true, read the status register. I guess it's like while status dot, while it's not stable. Is that what this is? Stable is, yeah, while it's 0, do nothing. I guess that's kind of it. Sure. Sure. Okay, so that like ran, and I guess we should breakpoint in here to confirm that it is not stable initially. So interestingly, that just doesn't get hit. right? If we take the breakpoint outside, it does, right? So I guess that's fine. I guess that's fine. Fuck it. Fuck it. And then can we prove to ourselves that this is working? So can this guy get used as like a clock source? It'd be I would love to see reset the chip. Yeah, that's probably a good idea. Oh, right. So you're saying that like maybe it's stable from the last run or something? Unplug, replug. Yeah, he still doesn't hit, but that was worth a shot. Worth a shot. Okay. So this guy's probably on. We just have no real proof of it, which kind of sucks. I would love to have some proof. But whatever. Can we like I guess it will become apparent when the UART is on. So we can just set up the UART clock source and just kind of hope for the best. I think that's probably the play. I think that's the play. The count register? Yeah, but it's just moving so fucking fast, right? I guess, well, maybe not. Like, if we have, let me think for a second. 12 megahertz clock, and we have uint 32 max, right? Is the, we only have 8 bits here, right? So, like, 12 megahertz, so it's like, what's like 1 over 12 megahertz times 255. Like, it's like we're saying like the whole thing is like a few microseconds. So it's like hard for us to use this in any way that's like helpful. I guess we could use this as our weight. So our like do weight here, we could do like x oscillator count is equal to 255. Right? Is that what goes in here? Yeah. He doesn't like this because and then how many times if we wanted like 1 second, this is can we like copy this 1 over paste so like 50,000 times ish should give us like 1 second. We could try this and see if the blinky light should like still blinks at approximately 1 time per second. 1 Mississippi, 2 Mississippi. Yeah, that's about right. That's about right. Where how do I angle this thing? See, that's a 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. Like it's about right. About right. So I think it's working. I think it's working. Pretty hype. Pretty hype. So we now have to pipe this shit onto the other guy. So what do our notes from happy hour say? We need to set this as like the clock source for clock Perry, the UART clock. So clock Perry. How the fuck does this work? Greetings. How goes it? Good. How are you? I think it was like there was some register in here that we just slap here. Clock Perry control and clock Perry selected. So here we just write the control register, probably, right? So clocks here has a base here. Do we have clocks base already? Do we have this number anywhere? No. Okay. We'll just do this then. And then Perry control is a volatile U32 is equal to base plus this as a pointer. Okay, and Perry, what was the other one? I think we don't need the status register or selected. I'm not going to read this. So I think it's literally just this guy. And then is the control registers, I wonder if they're like common. Like syscontrol has aux source. No, they are different. So we just copy this guy. So we say Perry control is a structure backed by a U32 who's reserved for 5 bits, then 2 bits of aux source, 3 bits, 3 bits. This fucking like the inclusive range fucks me so hard because like subtraction doesn't work properly. But it's okay. And then we have kill, enable, and then reserve from 12 to 31, which is 20. Okay, so this is, let's add this up. 8 plus 4 is 12. 32. Nice. It's the right number. Okay, and then we said that the way we were going to do this, we're going to be like write params. And then we just take out the reserved ones. Boom. And then we're like, self is a volatile Perry control. Does the compiler complain if the size of the members is greater than 32? I would assume so. We can check that in a second. Params is write params. Here we're like, this guy becomes a Perry control here. Nice. And then we're like self dot, we just read self. I bet you there's some like meta programming shit we could do here. Right? Regs with params. Because like this is going to be the same pattern over and over and over again, right? It's going to be like we have in, which is a volatile given some type. We're going to have some input of t and then params of any type. And then we're going to be like stood meta fields for each field in params. We're going to be like, here's our field, and we're going to write like var val is equal to in dot star. We say in dot star equals val at the end, and then in line 4 here we go like field val field name, I think, is equal to params. Yeah, it's something like this. And then here we're just like write regs with params, Perry control self params. Boom. That's kind of hype. That's kind of hype. So now we should be able to be like clocks, Perry control, right. And I guess really these guys should be optionals, I guess, right? Because like in reality, we don't know, like these are the things that we could set, but we might not care about changing some of these, right? So here, oh, this should be a type of params. And here we should be like, if this which I guess is shit. To some amount, right? Because this means that we're going to be doing some cycles that we don't need to do, right, for every null field, but not if this is comp time. I think. Which I guess it won't necessarily be. Yeah, so this abstraction kind of like blows. But I guess if you didn't want to initialize everything, then you would do the read modify write yourself. So maybe we call this like init. And maybe we just do this. Oh, wait, that's kind of hype. That's kind of hype. So here we're just allowed to pass like literally whatever the fuck it wants. And yeah. So here we're like field params field name here. And then when we write parry control, we just have to be careful about which things that we said. How do you select a whole block of code in Vim? I'm using % a lot to like jump to the other side of a curly brace, but I'm sure there's many ways. VAP, visual around paragraph, yeah, that's true as well. Okay. I don't know if these aux sources are always the same. It looks like no, right? Here they have PLL USB as 0. Here they have clock sys as 0, which is kind of fucked. So that's fine. We can just kind of do this here. So this is a U3. And we only really care about this one right now, the aux oscillator. We'll add the rest as we need them. How do you do non-exhaustive enums? Non-exhaustive enum, you slap an underscore in there. So that way we say other values are allowed, but we'll only ever write X oscillator. Yeah. Oh, but now he doesn't know the type of this thing. Which I think is, yeah, that kind of sucks. That kind of sucks. Having the fucking init params is necessary. We'll call this init. And then here we can take in like init params. That's fine. It's fine. We'll do it this way. This worked fine. And here we'll just say on init, you literally have to write everything. Sure. Aux source here needs to be a aux source, both here and here. Okay. And then what's the other ones on here? We have kill and enable. So I don't know why we would want this. So clock kill 0 probably. And enable equals 1. Seems reasonable. Okay, so like nothing's happening, but nothing should really happen here. Can we like... It would be nice to prove that this is on, but I guess we'll get there. I guess we will get there. I wonder if you can just like hook up a clock to a GPIO and I could like fucking slap the oscilloscope on there. That would be kind of cool if that was possible. Yeah, I wonder if you can just clock a fucking GPIO. That'd be kind of sick. You can drive your LED with the clock, but the LED will move too fast. But I don't know. Yeah, that would be like way too fast. I agree. But it would be cool if you could just be like... You can set it to PWM. So I could set something to PWM. Oh, clock. Wait, clock GP out 0. What is this? like general purpose clock outputs onto GPIOs with an optional integer divive. Wait, this sounds hype. This is exactly what I want. This is a good way to prove that it's working. Where the fuck are we? So how do I configure that? GPIOs, probably. I think it was 2.17 or something. No, that's ring oscillator. GPIO here, 2.19. Oh, I'm literally right here. Okay, how do I like set that shit? So I can set the function IO bank 0 func cell. That's here. What about like enable a GPIO interrupt list of registers. Yeah, this just isn't what I want unless the clock source is part of this control register, which I don't think it is. No. Maybe in clocks. No. Where would it be? GPIO. I don't even remember what the fucking thing was called. It was called clock GP out. This is the only place that that's found in here. Do I have an oscilloscope? Yeah, I bought one the other day. Exciting stuff. Exciting stuff. Ah, fuck. How do I... General purpose clock output. Optional integer divide, which means that that thing must be configurable somewhere. Gotta get to sleep. Good luck. All right, have a good one. Later. Proc. Oh, wait, maybe dormant wake. Raw interrupts. Time to ask the idiot. Yeah, I mean, that's not crazy. That's not crazy. Which register allows me to configure GPIO clock output in the RP2040 benchmark? Yeah, he's got function select. I hear there's a divider. How do I configure that part? GPIO control does not have it. I didn't see that. Clock div control. Oh, maybe that's what they mean, huh? Oh, there's also this clock GP out here. Oh, nice, nice. This is actually what we're looking for. Fuck the idiot. Okay. So we can configuring a clock generator. Okay. So then where are the so we have clock sources, clocks, GP out 0 control. This looks like what we want. Hell yeah, dude. Here we go. So this is where we set the divisors. Here, nice. Nice. This is it. This is it. So, okay. So we should be able to set some of those GPIOs. This guy. So like GPIOs 21, 23, 24, 25. Which we can look at the Pico pinout. Raspberry Pi Pico pinout. What does that look like? Is it this one? Pico and Pico H. So we're looking for GPIO 21. So I could look at this guy. I don't have the pins soldered, which is a little annoying. Unless 17 and 16, I do have those ones soldered. So if we just luck out, no such luck. But we can just tap the fucking orange, the metal part with the scope, and it'll probably be fine. Also, go to sleep. Good night. Good luck. Late up. So I think that's probably fine. It's probably fine. We can probably use GPIO 21 here. So we configure clock GPIO 0. Which is GPIO 0 control. Okay. And I guess this is going to be similar to this guy, to be honest. I guess this is just like a completely different clock. But I guess so it doesn't this won't really tell us if we've configured clock parry correctly. Right? Because we can't use clock parry as one of our inputs here. So I guess this doesn't help us. In which case, I don't really want to do this right now. Okay, fuck it. Fuck it. We'll just hope for the best. I think it's probably right, but we will see. Let's try to do some synchronous UART output and just see what happens. Let's just try it. Okay. So what did we say that we have to do? We set up clock parry. We don't have to look at clock sys. We're fine with that. Take UART out of reset. Okay, let's start there. So reset. Reset, reset, reset. It's like reset base or something. Resets base, maybe? Yeah, here we go. So the reset register, UART 0 or 1? Which one am I connected to? I'm connected to the one on the top left. So UART 0. We want to take UART 0 out of reset, so that's 22 here. So how are we handling reset right now? I think we are doing that in LED initialization, which is kind of silly. So we say atomic clear register from this mask of IO bank 0. So I think we can just say UART 0 here and say that this is 1 shifted left to 22. Okay. So we should be able to take UART 0 out of reset now. So let's just make a function here that's like UART in it or something. Or UART test or something, whatever, it doesn't really matter. And we'll say like reset. We'll do the same thing that we did here, which was atomically clear some register on this guy. And we'll only look at UART 0. Okay? Take this guy out of fucking reset. And we should be able to prove to ourselves that we can read from the UART controller now after doing that. So probably like UART here. So can we just read from some register here and see if it looks sane? I think that there were some like completely fucking fixed info fields. Yeah, here. So let's do that. So we have UART 0 base is this. So we probably want to do something that's like pub function UART here that takes in the base address and returns a type, right? Because this is going to be like, I guess it could be like parameterized. Yeah, I guess it has to be this way. So we say like base is equal to base. I guess we don't even have to do that. We can just say okay. So let's just start here. Perif. What is this thing? It's perif ID 0 is this. And we're hoping to get an 11 back from this guy, right? Volatile ether 2. Okay. So then we can be like, uart 0 is uart with the appropriate uart base, I guess. These being their own type seems kind of weird, to be honest. Maybe they should be instantiations, like with, but it's fine, it's fine. Do you have Copilot from him? No. No. I'm constantly shocked at how shit, how shit, AI is. Every time I use it, I'm just like, it's worse than I thought it was going to be. And so until I feel like it's useful, there's no shot I'm integrating into my editor. Also, there's no fucking way I'm sending all of my fucking coding to, like, the internet. Like, just why? That's crazy. It's my code's for me, sir. He says as he posts all of his code on GitHub. But, like, you know, theoretically. This is 0. That's not good. But I guess we didn't run uart initialization, right? We did want to do... We didn't take the chip out of reset yet. So it's kind of expected that this doesn't work. As he streams his code live. Yeah, there's a lot of reasons why what I said is fucking stupid. But, you know. Okay, there we go. Sick. So the chip is successfully out of reset. Let's go, baby. So that's step 1 complete. So take it out of reset. Configure pins for uart output. Oh, right, because we need to pick the appropriate GPIOs. Yes. So the GPIOs in the top left need to have their function select these guys. GP 0 and 1. We need those guys to be func-celled for function 2. Okay? So we've done some function select for the LED before. Here. Set multifunction as SIO SD code, GPIO init sets is fine to set everything to 0. So it seems like we should be able to say here, GPIO function of uart is 1, 2, 3, 4, 5. So this should be 2. And then we should be able to say here that we want to set the GPIO 0 and 1 to uart. Okay. What does this return us? This returns us like the GPIO bank control register. Like IO bank. There we go. So this guy, we're setting all of these to 0, which is, I guess, fine. Because that's what it says in the data. That's what they do in the SDK, so fuck it, I guess. Okay, so we set these guys to uart. Hype. Then what? Then what? We have to set the baud rate. And then start trying to slam some shit. Okay. Sure. Let's go back to the uart section. And just look at the registers. So data register is where we're going to start writing shit. We need to set the baud rate, which is these guys. Integer baud rate and fractional baud rate register. And then control register to enable transmission. So I wonder, let's just try to do the stupid thing first. Let's just do a stupid thing and enable transmission without really thinking. and then start slapping some data into the data register, and let's just see if that does anything. And if it doesn't, then we can think a little harder. But if it does, then we're kind of chilling. So we have base plus this. Oops. Okay, and then is uart cr control? Yeah, he says control. Okay, so I guess we make a struct where we can actually just say the only thing we care about is transmit. How do I want to do this? Let's just do this. We'll say like control tx enable is 1 shift left by 8. And for now, we'll just set this guy to transmit enable. Oh, and uart enable. We probably want the uart to be turned on, huh? Yeah. What about this? I don't know. Loopback enable. Yeah, it seems like we just want. I guess loopback enable is nice for testing a little bit, but I think we just slap transmit enable on here and see what happens. I think. I don't know. Let's just see what happens. Let's just see what happens. So then we slap some data into the data register. We're like, let's throw you some shit, please, sir. So this is base plus 0. Okay, and we probably want to model this correctly, I guess. Okay. So what's in here? We have data, we have FE, PE, break error, overrun error. Reserved is the rest, which is 20. All right. Then most of these guys are read only, so it's fine. And so we're just going to be like data equals. We're going to be like data is equal to I think you have to do it like this. Because you have to do like a full register write every time. I don't really know what this generates, to be honest. I'm kind of curious about what this is going to do. I hope it does like a U32 store, but I don't really know. Kind of curious. So move into R0 the character A. Hold on. Can we mark this with another breakpoint on the other side? So he's like, move the value of 97 into register A. He loads register 1 with the address, and then he just stores that shit in there. So, like, isn't that like a fucking problem? Store B is store byte now. Oh, yeah, true. Which seems bad because we need like 32-bit writes. What did it say about U32? Like somewhere it talks about registers. Bus fabric. So it says somewhere that everything is like a 32-bit register. And I don't remember what it said happens if you don't write 32 bits. Maybe it was in like the intro. Pinout, no. System description, bus fabric. Each register block is this thing. Oh, here. Memory mapped I registers ignore the width of bus read-write accesses. They treat all writes as though they were 32 bits in size. This means that we cannot use byte or half-word writes to modify part of an I register. Any write to an address where the 30 address MSBs match the register address. Right, so if the 30 top bits match the register address, then it hits. So this is sketchy, right? By doing this, we are writing to the whole thing, which means that I'm honestly... That's fine in our case, because the other registers are 0, but we should note here that this is kind of odd. So we'll say that, like, note Zig will probably generate a 1-byte right here. However, what do I say here? The Raspberry Pi Pico will interpret this as a 32-bit write from R0. However, the other elements of uart 0 are not readable, are not writable. So this is fine. Shouldn't you make it a compiler somehow? Part of me wants to say yes, but part of me thinks that this is okay, to be honest. I don't think it's like necessarily wrong. It's just kind of fucking weird. On the other cases where it would be wrong, then maybe. Right? It's almost like these like packed structs. Like if we wanted to be super fucking careful, we would make it so that you have like, you could do like data wrapper, right? You could do something like this, like register definition, and then you could take in like a type here and return a type, and then here you could like create functions that write to individual components of these things or something, but I don't fucking care right now. We know the rules, so we'll just be careful. You know, I think it's fine. So we haven't set the baud rate yet. We do need to do that because I think the baud rate by default is invalid. So let's go back to that guy. So where did baud rate calculation? So I see. So you do the division. Do we want to do this in code or do we want to do it by hand? You have like fractional and integer parts of a divisor here. And the formula is clock over this equals this, yeah. So we know our UART clock is 12 megahertz, right? Because we don't divide. When we set up our clock parry, yeah, it seems like it's fed straight through, which means that our clock here is 12 megahertz. Divided by 16 times 11,500 is equal to 12 divided by 16 divided by this is 6.510. And so then we just say uart 0 dot, we need the registers here. IBRD is pointer from int base plus 24, and FBRD is plus 28. Okay. This is 6. And this is 510. FBRD is this many bits, so that should be fine. And then I'm just gonna slap fix me's on here. And say technically overwriting reserve, but I don't want to deal with that right now. Set baud rate to brrrt. Yeah. Brrrt, 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 brrrt. So fucking stupid. Okay, and then so once we've done all this, we like turn on the chip, we set the baud rate, we enable transmission, and we write some data here. I think that if we just did this in a loop, where we wait for the status bit to tell us that he's fucking donezo. Receive status register. Here, I think it's this one. UART FR register, flag register. I think this is the one. Flag is base plus x018. And here we're looking for transmit FIFO full. So if the FIFO is disabled, which it should be by default, this bit is set when the transmit holding register is full. So I think we just wait for this. I think it's like while true, we write some data, then we say while uart 0 flag and 1 shifted left by 5 is not equal to 0, we do nothing. Right? Just curious, what program do you do for work? Nothing right now. This is the life, dude. Just whatever the fuck we feel like for not very much money. It's hype. And so I guess I'm hoping that if we did everything right here, we're just gonna see like a fuck ton of A's on the line. That's what I'm kind of hoping. Now, we probably didn't do everything right, but we didn't. Okay. So I think maybe we whip out the scope. Hold on, I gotta get some wires and plug them into the right spots. And let's see if we're at least seeing some traffic, right? Whether or not it's actually being interpreted correctly on the receiving side. That's like completely different from if we're sending anything at all, right? It might just be confused. So first of all, if we hit breakpoint here, source file is more recent than executable is concerning. Okay. Yeah, so we are just kind of ripping through this shit. Are you waiting for TXFF? I think it's busy instead. Is that true? Transmit FIFO full. Yeah, so I'm saying while this thing is full. Yeah. While this thing is not 0, that means it's full. Does Cat have any idea of baud rate? I think you might need something like screen or minicom. Yep, both. That seems very likely as well. I've had success with just catting it in the past, but you are right that it's likely that that's wrong. Okay. So let's which pin is like the transmission? It's the top one. So I should actually only need one wire here to go into one of these pins. You guys can't see what I'm doing, but I swear I'm plugging something in. And then I have a ground wire already. I can just turn on my oscilloscope and clamp those motherfuckers, which again, you guys can't see, but I promise it's happening. I guess we could do this. We got a couple lines to hit, so there's this guy here is my right line, and then this guy here is my ground line over here. And we can hope that something interesting is happening on there. We can see. Okay, turn the oscilloscope on. We wait a second. I guess there's nothing interesting to see on the screen here. So hand wavy. I am seeing just a hard up line here, but it's probably because we're not running. Transition. Let's get the fucking hello, why can't I fucking... Oh, because the oscilloscope is holding down a button. Okay. So, bad news bears. Oscilloscope just shows, like, straight line. Right? That's not great. That's not great. Which means that I guess we just need to look closer. Oops. This fucking off patient is dead. Yeah. So I guess I just put this over here for now. And what do I want to do here? So I guess I would like to know if this is happening at all. So also it would be nice to read these back and ensure that they're right. So maybe we just like breakpoint in here. If uart 0 flag and 1 shifted by 5 is not equal to 0, I guess we can just put a breakpoint in the while loop. Let's start there. So let's see if he thinks he's transmitting. So he does hit that, assuming that this is the only breakpoint. There's another one here. Let's get that one out of here. So this is the only breakpoint, which is being hit, which is kind of hype. Do we hit outside the loop as well? No. No, so he's like, I'm full forever and ever, right? Which is not good. So why would that be? Did you set TXE on uart CR? I think so. That's what I think this is supposed to be. Right, so TXE is supposed to be 8, 1 to the 8, which it is here. But we might not have configured something else that we're supposed to configure. Like all of this stuff, line control register, we didn't do, which seems kind of bad. So what if we just don't configure this? FIFOs are disabled, 2 stop bits, odd parity, parity is disabled, Word length is 5 bits, which is kind of odd, but fine, right? That should still like do something. And stick parity select. 0 stick parity is disabled. 0 sound disabled sounds great. So I'm not like fully convinced that's wrong. Do we need to... So we know the chip is on because we can talk to it. This is the flag register. So this, so we have transmit FIFO empty, which depends on the line control register, but that's different than... I guess we could look at transmit FIFO empty as well. Empty and full are different. So we are seeing this guy be always full though. And we should probably check here that it's empty before we do anything, right? Right? Before we write anything to him, he should be empty. Did you look at the busy bit? No, but maybe I should have. Maybe I should have. Okay. So we don't hit this guy either. So we're seeing that the transmit FIFO is full before we even try to write to him, which is interesting. If the FIFO is disabled, this is set when the transmit holding register is full. That's weird. That seems weird to me. So, first of all, are we positive about this guy? I thought FIFOs were disabled, but I had to work and didn't see if you enabled them. But this says that if the FIFOs are disabled, if it's just like that one register, it should be fine. Like if the FIFOs are off, then the flag should return if the holding register is full. But maybe I'm wrong here. Let's check busy instead, maybe. Because this does seem like a more correct thing to look at. So busy is 1 shifted left by 3. Which again we're not getting. So he's saying I'm busy off rip, right? Unless we're doing something stupid like this. The brackets matter? No. Okay, so here we're like, if this is not equal to 0, breakpoint, and is not equal to 0. So he's busy before we even do anything, which is very confusing. Can we look at, let's do this. So he's... Can I do binary? No. So he's like... Oh, maybe we do have to disable flow control though. We might be onto something where we might have to explicitly tell it flow control is off, or else he might be waiting for that. So this should be off. Can we look at the control register? Okay. So this only has 2 bits set, which are the ones that we asked for. So we set tx enable and uart enable, so that seems good. Very strange. Very strange. Okay. Can we look at maybe the C uart in it? Deassert the reset. Done. Enable clock parry. Done. Set enable bits in the control register. Which I think we've done. So he sets a lot of stuff in here. Okay. Enable FIFOs, set the baud rate divisors, set the format, which we're not doing, which maybe we should. Okay, so he enables FIFOs. We shouldn't need to do that. UART set format is probably setting the like line feed thing. But again, I don't think we should need to do that. Maybe we do need to write to like the line control thing one time just to make it happy. That's possible. So we set this, we set this. These are flags should all be read only. Receive status error clear register. Then data register. What's in here? Received. Yeah, so none of this really matters for us, I don't think. I'm assuming we have like interrupts off by default. But I mean, maybe not. It might be interesting to look at this guy. So this is this plus hex 38. Okay, so that's the interrupt mask. Everything is 0, where 0 means don't fucking do shit. So no interrupts. So it's not like expecting us. It's not like we're like haven't cleared an interrupt and he's like stuck, as far as I understand, right? My best guess here is that maybe we have to write something to the line control register for him to like think that it's okay to start doing anything. You know? You know? So can we just write like oopsies, wrong button. What is this thing called? Why am I not auto-completing? I must have fucked something up here. Okay, so this should be like 0, 1, 1 for 8 bits, 0 for disable FIFOs, and I don't care about these guys. I think that's fine. If this bit is set to 1, a low level is continually set on the UART XP. Okay, sure. Doesn't matter. Okay. Yeah, so I don't understand why it thinks it's busy. You know? If this bit is set to 1, then the UART is busy transmitting data. Can we look at this like right after we fucking turn that shit on? We're like if we take the chip out of reset and then look at that value, are we hitting that breakpoint? 250? No, so we don't get a hit here. Do we hit it here? No. Maybe it's after we enable transmission? 252? No. So it's only after we set the baud rate? No, not even then. Oh, I'm a dumbass. I actually have to copy paste the flag value as well, huh? 250 again. No. 250 again. Not here. Do you have a background in embedded programming? Yeah, I worked on security cameras for a while. So a little bit. Not quite this low level. We were kind of more like a C++ user space app. But, you know. What the Oh, wait a second. We're not busy here. I'm a dumbass. Wait. We're not busy until we write the A. And here I didn't double check these brackets. Not that I think it should matter, but... Oh, wait. Are we just chill? Yeah, we're just fucking chill. I'm just a dumbass. I'm just a dumbass. I'm just a dumbass. Check that shit out. Look at that. That's doing some shit, dude. You know, the thing is like configured wrong, but we're seeing some fucking data, which is really all that matters. So I think that I just had the breakpoint here and thought that it was inside the loop or something. I don't even know what I thought. We got blinds moving and shaking. Yeah. So if we go back here and we cat now, still nothing here. So, oh, probably because we're not running the thing. Okay. So now we can probably assume that this thing is configured wrong. So can we do picocom? Let's see if we can like actually get some reasonable data out of this thing. So we think we have no stop bits. How do we like fucking... So we think... So he says that you need at least one stop bit. Let's look a little closer at that line control register. Line control, baby. It sucks too because I was looking at the scope, but with the breakpoint enabled. So I just was like fucking myself. That's pretty funny. It's probably 8 and 1 by default. Well, it's definitely not 8 and 1 by default because I had to set 8 here. So it was 5 here by default. Where are my stop bits? So bits set to 1. 2 are transmitted, so it's probably not. And then parity is disabled. So parity off. So how the fuck do I use this fucking program? Baud is 115200, we think. We can probably check that on the scope. Parity, none. And then stop bits, 1. Dev T2I ACM. Okay. How the fuck do I quit this? Picocom quit. Control A, Control X. There we go. Thanks for using Picocom. Okay, so that's pretty interesting. So that indicates that we think we're sending A's, right? And we're clearly not. Yeah. Why can't I get out of this fucking window anymore? Control A, Control A, Control X. There we go. That looks like a baud rate mismatch. Yeah, I agree. Now, I guess probably... Oopsies. Just fucking dropped my mic. Unscrewed itself. I guess if I could figure out how on this oscilloscope to set the time period correctly, I guess I just slap the auto button and just see what it does. And then can I like pause this thing? How the fuck do I pause? Okay. So let's... You know, I got like a time period and some lines on this thing. So I guess probably using this to try to figure out what the current clock is probably reasonable. So on this thing, it says that my horizontal time is 20 microseconds. And I think that I'm seeing like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22-ish. So I'm seeing like 22 bits over 0.00002. That's about right. No, that's an order of magnitude too high, no? 115200. Yeah, that's 115200. Order of magnitude too high. Bash Bunny, thanks for the raid. Thanks for the raid. What's up, you guys? What's up? Since there are a lot of you, we will give you the context again. We'll give you the whole spiel because there are a lot of you. Apologies for those of you who have already heard it. But we are working on trying to get the long-term project here is we have this controller. He's got paddles on the back, okay? And those paddles are configured in the firmware of the controller to remap to other buttons, right? So I can map the left paddle to A, right paddle to B, and then when I'm playing like shooters, I can keep my thumbs on the sticks a little better, right? I'm on a computer though, and computers can interpret more than the buttons that an Xbox controller has, and so I want the paddles to be their own buttons so that I can map one to like my push to talk button without losing a button on the controller, right? Right now I have to map them to the D-pad, and then I lose the D-pad as like actual D-pad, right? And that sucks. I want to have the D-pad and push to talk. And so, I'm on this quest to try to reverse engineer the firmware on this guy, right? So we've popped this guy open. I looked at the firmware package a little bit. It didn't really seem like I was going to get anywhere. It seemed like it was like high entropy and, binwalk didn't show me anything. I didn't find any like compressed data. Pop this thing open, find this chip. This is probably the brain, but I Google this thing, find nothing, right? So our only lead right now is this chip over here. I Google this chip and I find something. It's an EEPROM. So we're like, maybe we can dump the EEPROM from the guy, and maybe, just maybe, the EEPROM contains the firmware image, unpacked, unencrypted, or whatever. Probably not, but it's my only lead right now, and it's kind of fun to look at. So we bought a Raspberry Pi Pico. He's got I2C. I have this guy hooked up to some like duplicates of that EEPROM. I bought some on DigiKey, slapped them in there. And instead of doing the same thing, which is like using the Raspberry Pi SDK to try to run I2C and read this guy, we're on an adventure to kind of do all of that ourselves. So we have a Zig program that we've set up that's like got his stage 2 bootloader hooked up, that's like CRC'd correctly, does stage 2 boot, and gets into like our program, where our program is kind of this guy for now, right? So we have like a little blinky LED example, and we're trying to upgrade from blinky LEDs to printf. So we've been kind of reading through the system on a chip RP 2040 datasheet, trying to get everything up and running. We've configured a clock source for the uart on this guy, right? Uart is essentially, we have like 2 wires hooked up here that go to like, I have like my PC over here, and then like on my PC, there's like a USB port that goes to this like Raspberry Pi debug probe. We'll call it debug probe, DP. Debug probe here connects to the like UART pins on the Raspberry Pi, hand wavy. He connects to some other things, but this is all we need to care about for now. And this is essentially like read line, write line, right? Essentially. And we just got to the point before you guys rated where we see some proof. If we kind of slap this down. Ah, fuck, I hit the mic again and it unscrewed. We see some proof that this guy is sending data, right? So that's a really, really good sign. That's kind of like our first real like, oh shit, something's happening. But what we are not seeing is that the data is correct, right? So if we run that program, oopsies. Hello, GDB. If we run that program and we listen to it, we think we should be seeing a list of A's, and we're not. So we were just trying to check if the baud rate was correct, and if my math was right, it's definitely not. And so we have to fix that. So that's the quest we're on. Thanks for the raid again, Bash Bunny. Much appreciated. Hope you guys enjoy what you see, but if not, no big deal. It's not for everybody. We're just gonna keep going. Hope you guys had a good stream over there, and yeah, let's just get into it. So I just want to double check this again. It could be that I misread the oscilloscope. I'm actually thinking that I probably did. I think that when it says h equals 20 microseconds on this guy, he could be talking about the whole width of the screen, which we assumed, but he also might be talking about the width of one cell on here. And if I count these cells up, there are 12 of them on one screen. So let's think about that. So how many fucking bits did we count on this again? It was like 20 something. I'm gonna have to do the counting again. I apologize. You guys don't get to see this part. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21-ish. So we have 21 bits on the screen over 0.000020 for 20 microseconds. And then we think, but there's 12 of those. So divide by 12 times by 12. Fuck. 21. Fuck. 21 over 0.000020. But then this time is larger than this. So I think we divide by 12 now, which is 87, which, like, based off of our, like, really, really approximate number, could be right. We're looking for 11,115,200 here. So it could be right? If we're actually seeing, like, 22 bits instead of 21, it would be 22 over 0.000020 times 12. No, divide by 12, divide by 12. Still would be a little short. Which is probably a clue here. That sounds like a reasonable clue. I wonder if this oscilloscope has a way to, like, measure. I don't really just want to, like, click buttons on this thing in a way that you guys can't see, though. It also... Oh, cursor measurement. Wait. Channel 1, he can measure frequency. That's a thing he can do. Hold on. You can set 2 cursors and measure it. Oh, yeah, that's true as well, huh? Probably. That sounds likely. How the fuck do I get out of this menu? Dude, I don't know how to fucking use this thing at all. Probably press menu again. Where the fuck I... Oh, yeah, he says frequency on yellow is 25 kilohertz. Is that... 25 kilohertz. Wait, we need to send a message. If we're gonna measure the frequency, we want to send something that has the bit pattern of alternating. Right? Because we don't know, because he's gonna measure something too short otherwise. So we can test this by replacing this with 0B1010101010, right? Just alternate as fast as you fucking can. And let's see if the oscilloscope measures something different now. So he says he's measuring a frequency of 37.58 kilohertz now. But then also because of stop bits, then that's not really quite right. Okay. We could also try slowing down the clock. Fuck. Can I zoom in? Is that a thing I can do here? Surely. Up? Right. Left. No. Sorry. It's really fun for you guys to just look, like, have me read to you me pressing buttons, huh? That's kind of hype. Yeah. Well, I've only used large oscilloscopes, LMAO. Yeah, dude, me too. And even then, I wasn't very good at them. Okay. I mean, it seems likely that our clock calculation is wrong. I think that it is worth revisiting this. Anyone know the name of this keyboard? It's a Durgod K320, but I don't know how much that matters. So we could maybe check what the SDK sets for these values and maybe compare. We're probably doing something fucking stupid. It's worth a shot. Give me a sec. We're loading up another environment. I'm pretty hyped right now. Dude, me too. It's crazy. I don't know like what this feeling is, but there's something just like so fucking satisfying about just like, you know, stuff working. Or like, yeah, there's just something so satisfying about whatever the fuck is going on. Where does this guy say that they do their uart initialization? uart.c lines 42. So this is rp2 common, uart.c. Maybe try testing a few of the standard baud rates. But like we've configured something based off our input clock intentionally. So whatever, I don't think that it's likely that it's just some standard. I think it's likely that we just set the fucking clocks wrong. Okay. So here 8. What the fuck are we looking at here? 8 times the clock rate in hertz divided by baud rate plus 1. Okay, hold on. Hold on. 8 times 12, 1, 2, 3, 4, 5, 6, 12 megahertz divided by the baud rate. X plus equals 1, and then X shifted right by 7. This needs to be floored. Int X shifted right by 7 is 6. Is that what we wrote? Yes. Okay. Then their lower half is this. So baud rate div and 0x7f. Shift right by 1. 2. This is unlikely to be what we wrote. This does not... Oh, 33. I got the brackets wrong. I don't think that's what we wrote. We wrote 510. Okay, I'm going to slap a 33 on here. Just to see. But then we're going to have to revisit, like, why. Okay. Continue, please. Thank you. And then picocom. Okay. I mean, clearly that's not it. I mean, we are seeing, interestingly, that it's different, right? So the baud rate being wrong is a likely good clue. But and then we should double check stop 1, parity no. So they use stop none, parity no, data bits 8. Can we just double check that we're setting our line control parameters correctly? Line control, we did this. Line control. Check baud rate on the probe. Maybe UART is not getting 12 megahertz. Yeah, I mean, that's what I was trying to do before. But it's just like, I feel like it's hard to measure. But maybe that is the play. I was struggling. But yeah, I guess I can just, if I can get it to zoom in and just measure the difference between 2 exact points, then maybe we can chill. Maybe we'll get the answer. So word length, we set this to 765. So that should be 8. FIFO's disabled. 1 stop bit. Odd parity. but parity is disabled. Yeah, so I think that's right. Yeah, I guess maybe it makes sense to try to learn to fucking use this thing. It just sucks because you guys don't get to look when I'm doing that. I don't know how to like zoom in. I have like a select button that lets me press up and down, which will change the. Oh, here. Wait. I think I've found something. Uh. Yeah. I'm finding something. I just don't know. So I can like slide the image to the left and right, which doesn't really seem that helpful. I can measure voltage. I don't know if I can measure time exactly. Doesn't seem like it's telling me where time is moving. Yeah, I'm gonna. While I think that is the correct answer, looking at the oscilloscope, I think it's not the best answer for stream, unfortunately. So maybe we. Oh wait, we're not writing like a sane value here. Not that I think that should matter. I guess we should see one constant value no matter what. Wait. A is one of the characters. It's one of them. That's a good sign. What if we do like. What if we sleep a little bit in here? What if we do this like one time? Let's just write 1A. 1A. Okay. That's interesting. Try B. Yeah, that's not crazy either. Okay, so that's a good clue as well. That's a good clue. So it could be that because transmit enable is always on, I wonder if like the fact that we're still oh, this is while true. Oops. Okay. I just want to try sending one character one time. Monitor reset init. Okay, so he got nothing. Interesting. Okay, so while this is supposedly the busy flag, let's just try that again. Okay, and then maybe it would be interesting to look at the difference between a capital L and a B. You know? So can we do like format this as a binary number? Okay, so we have L, B. Okay, so we can tell that there's some sort of like shift here, right? Like here we're seeing the same number of ones and O's, they're just not lined up correctly, right? And if we did the same with X and A, this is not as clean, right? So like B to L is like a pretty clear oh no, it's not. It's not a rotation. So they're kind of wrong in the same way. Right? So here B we have 1 0 like okay, so L 1 0 0 1 1 0 0, right? Here for B, we have 1, 0. We're missing a 0 that would have to be before this 1, 1, right? And I think it's the same for X to A, where we have 1, 0, 1, 1. And then here we have 1, skip the 0, 1, 1. Something to do with 5 bits per word. Did we not fix that, though? I thought we fixed that. But I guess you're right that, like, we could look. It's weird that changing this doesn't change anything. I wonder if the command line arguments need to be in a certain order. Data 5 versus data 8 weirdly doesn't change the behavior. I'm assuming right now, okay, I want to double check here that if I go like, I don't know, 9600 here. Okay, so that does behave differently. I'd also be curious, maybe let's try setting a baud rate that's lower. So first of all, we need to figure out why we got this fractional baud rate calculation wrong. This is probably decimal. 510 out of, what is like the fractional baud rate register here? We were using decimal there when it should be in base 2 or something. So we're like 510 out of 1000. I'm so stupid. 510 out of 1000 is 0.51, of fucking course. But it should be like just over half, right? We want that in base 2. Maybe. You can calculate the 6-bit number by taking the fractional part of the required baud rate divisor, multiplied by 64. Okay. That makes sense. Okay, so that means that our calculation was right. We just had this field wrong. So this is 99600. So we do 12 million divided by 16 divided by 9600 is 78.125. So we write 78 here. And then 0.125 times 64. I guess we just do this. Cool. Let's see if we get a more reliably correct thing by doing that. So data A, 9600. That's pretty exciting. So we're actually getting the same incorrect data. That's really fucking weird. That's so strange. Okay. Data transmission or reception. Data received or transmission is stored in the FIFOs, blah, blah, blah. But what if I don't have the FIFOs on? And remains asserted high while data is being transmitted. Busy is negated only when FIFO is empty and the last character has been transmitted, including stop bits. Interesting. Receiver is idle and a low is detected on data input. We're not receiver. Additionally, you can disable FIFOs. In this case, the transmit and receive sides of the UART have 1 byte holding registers. Yep. Overrun bit is set when a word has been received and previous one is not yet read, but we're not reading, so it doesn't matter. Interesting. We must just have some fucking there's just something that we haven't set up that we should have. Modem status interrupt is asserted if any of these guys. I don't know what this means. I don't really know what like I don't even know what the modem is in this world, right? Where's our like fucking block diagram? This guy, right? Like, which of what in this is a modem? I don't fucking know, man. like a transmitter being a modem sounds kind of like that's what my modem at my house does, right? The fucking modem takes the internet from the internet and puts it into my computer. But like, what is it, you know? We could try We could try to like, you might be overwriting the value we're sending before it is sent. Try sending bytes one by one with some sleep and test. Yeah, that's not a bad idea. So like here we're like waiting for the busy flag, I think. But yeah, it doesn't seem crazy to do like do wait in here, which should sleep for around 1 second, which is way too long. So let's kind of drop that down a little bit. But that is a good idea. Monitor. What am I doing? GDB. And then is this guy... Oh my god. I'm set up for 9600 bits per second. Okay. So now I'm seeing nothing? Which is... Which is different than if I do this? What the fuck? Is this just not returning? Breakpoint. It should be 11:5200 anyways. I slowed it down on purpose though. Why? This might be stupid. You added a delay between bytes. Bits are still 11:5200. No. Here I set the baud rate here to 9600. Or, yeah, 9600 here. This is what it should have been. This is what should be happening. Yeah. Okay, so that's also kind of interesting. How come, like... How is it supposed to sync the fuck up? Right? Like, if I'm sending nothing, am I supposed to send nothing? You know, is it like, is the wire just supposed to be fucking flat in that case? I would kind of think so. I wonder if you have to set data, then set transmit enable, then disable it. Or something like that. Or like, uart. We just like, you know, like what's supposed to be on the fucking wire here? Data framing. Idle, high. Then we have start bit. And he's like, yo, something's coming. Data bit, next 5 to 9 bits. Parity bit, stop. So here so it must sync up by this start bit, right? So, okay. So I guess looking at the oscilloscope, the line is high. And can I trigger this guy on like a falling edge here? Trigger edge low. Okay. And then will it just trigger when I start? Maybe it will. So here, if I'm just like, write 1B one time, right? Will I see that on the scope? That'd be kind of cool. I kind of don't see anything on the scope, but I also don't know if my trigger is set up right. So can we turn this back on? Oh, he's mad that I'm commenting out the flag value. Oh. That's a pretty good clue that I was doing. I think that I was just checking if the line was busy, like before I ever ran the loop. I think I was overwriting the data as I was running. Actually, that seems like the type of bug I would write. Okay, so now I'm seeing nothing. The scope also is seeing nothing, which makes me think this busy flag check is wrong, and this has been broken for a while. This is volatile, so it knows. Oh, I'm a dumbass. Hold on. This goes here. We have to read it every iteration of the loop. Okay. Now, I feel like it was doing more before. I'm gonna undo a bunch of times. I don't really know where this was working, but now it's like really not working. So I guess this was kind of the state we were in when it was doing something. Yeah, okay. Now, is this some language where the const flag is making a copy of the value of a reference to the register? No, you were right. I did the wrong thing there. I was definitely doing the wrong thing. I should be doing it like this. So it did indeed only read once, for sure, yeah. Okay, so this is saying if the flag and this is not equal to 0, hold up a second. And we're seeing, okay, the same shit. So this is still broken. I just want to, let's double check this flag value again. So this is register 18 offset. So hex 18, right? We wrote hex 18? Hex 18, cool. So that's this guy who has a busy flag here. Uart busy, this is read only, and this bit, if this bit is set to 1, the uart is busy transmitting data. Then we can go all the way until this has been sent from the shift register. This bit is set as soon as the transmit field becomes non-empty. Okay. So it feels like I wonder if there's like an example of the just slapping data on the line shit version in the SDK. Because maybe we're doing something stupid here. Because it feels like our baud rate is like approximately correct. And it feels like we're like overwriting our own data as we're writing or something. You know? Just kind of feels that way. So it was a rp2 common uart.c. And do they have an example of like, oh, this doesn't have lang d enabled? Let's go to another terminal where we have the stuff we need. rp2 common uart. So is there an example in here of like writing? No. Why not? Maybe in the SDK examples, they have uart in here. Hello. So they have uart put c raw, write blocking. So while they check, while it's writable, while it's not writable, which looks at txff bits. Okay. And then data register. So they're doing essentially what we're doing. Very close. They're not looking at the busy. That would be using this tx wait blocking call. Wait for this FIFO to be trained. So, I mean, that's very similar. Very similar. So they're looking at this thing and they're checking if this thing is greater than not equal 0. And then they just fucking slap the value into the data register. I mean, we could try looking at the TXFF bits. And we could try not disabling the FIFO as well. So we could try that, I guess. So it was the TXFF is 5. So does this do something different? Okay, basically the same shit. You can send 10 Bs and count how many you've received. I guess we could, I mean, I'm kind of curious now. What happens if we just try to send 10? I know that's not really what you said, but so we run picocom here, monitor reset init, continue. 1, 2, 3, 4, 5. That's interesting. Very interesting. Sus. Do you have music on off stream? Not right now. Sometimes I do. Not this time. Which is fishy. Definitely fishy. You know, on a whim here, what if we just halved this baud rate? So that's 48. Oh, wait, doubled? If we want more stuff, it'd be 1892. Just on a whim. I don't really think that's going to be it. Yeah, of course not. Of course not. Fuck. I'm down to try turning on the FIFO and just seeing what that does. So I think it's on the line control. We set FIFOs here on bit 4. So 0, 1, 2, 3, 4. Kind of down to see what that does. And then, oops, wrong pair bit rate. So it's 9600 here. That's so much more confusing. So much more confusing. So if the FIFO is off, wait. What if my clock is just not perfectly 12 megahertz? Is that possible? Try slapping some non-standard baud rate on there. Can we? I just want to look at the fucking clock again. Like, where is? I've downloaded this thing like fucking like 40 times. Have I not? this is Pico here. So design files. I'm like, it's supposed to be 12 megahertz, I thought, but I could be wrong. I could have been wrong. 12 megahertz? No, okay, so that is right. That's right. Qatar, thanks for the tier 1. Much appreciated. So, why? Why? Unless we have a clock divider on our UART clock by mistake, which I don't think there should be. What is it? It's parry, clock parry. So typically runs with clock sys, but allows peripherals to run at a consistent speed if clock sys is changed by software. Okay, so we changed clock parry control to come from the X oscillator, right? We did that, right? Right? We're confident that that happened? Parry control in it from X oscillator, which is 4. Yes. And then this guy is enabled and kill is off. Okay, sure. So fairly confident there. Then we like this guy's come out of reset. That's fine. We're confident that he's out of reset because modifying the values in this thing does what we'd expect. Okay. Then we have GPIO control here to set the pins to UART. Confident that that's working because we're seeing something come over the line. So that's cool. Transmission enable and UART enable, also confident in that. That also looks like it's working. I'm very not confident in this. I'm curious about what if we tried to set the baud rate to a perfect divisor of 12? Right? So we're like, just divide 10 times. So that would give us a baud rate of 120,000. Which he is not liking at all. Surprisingly. Let's just double check. Oh no, because it's there's a times 16 in there. Hold on. Wait, UART. So it's integer it's UART over 16 times baud rate. Is it? So it's UART over divisor is over 16. So or maybe I had it backwards. UART over the 12 megahertz over this is 16 times the baud rate. Yeah. So what if we just set the clock divider to 1? Maybe that's the play. We set it to 1. And then that should be 12 over 16 is our baud rate of 75, which is too much. So then we do 10 here. And then we try a baud rate of 75. 12 over 10 over 16, 75,000. Okay. So we just give us some really simple fucking... Okay, I mean, then that... I'm fairly confident that the baud rate is right then, right? Surely. Surely it's correct. Because, like, we're seeing, like, the same shit. It's much more likely to me that we're using the UART controller wrong. Right? Especially because if we turn on the FIFO, we start getting something completely different, but reliably the same, broken different. So like the fuck. I would love to figure out if I can get this oscilloscope to like show me if what I'm doing wrong. At least it's deterministic, yeah. Right, so I have like something on there that seems like a consistent set of lines. I just picked up the board by those wires. That's probably not great. And if we understood what is supposed to be coming over the wire, that might help. So we're supposed to be seeing like a start bit and then the values of what? So it's ord B. Format this in binary. Right? So we're supposed to be seeing, this is 1, 2, 3, 4, 5, 6, 7. So we're supposed to be seeing 0, 1, 1, 0, 0, 0, 1, 0. That's what we're supposed to be seeing. It might be the other way. Then we are supposed to be seeing this prefixed with a start bit, right? So it's supposed to be high followed by a start bit, then the B, then a stop bit. So how many, like, is the stop bit mean go high? Yes. So then we're supposed to be seeing like something like this. Okay? Now, can we if I then punch in what I'm seeing on the oscilloscope, I'm seeing like 1101, 00, 110. Maybe that's 3 zeros. I'm seeing something like this. So the 3 1s. Remember, like, this is the character we're looking for. Which I guess I'm not really seeing in there at all. But it could be backwards, right? So if it's going 0, 1, 0, 0, is that something we're seeing? Yeah, it's strange. Strange. This is, I'm pretty sure this is what I'm seeing on the scope. Pretty sure. Let me try zooming in a little bit. Or out. It's pretty hard to tell. It's hard to tell. It's like you're missing a bit, which kind of lines up. Oh, you know what? Okay, let's go back to the other version where we're not using the FIFO, where the values I was seeing from Picocom, at the very least, sometimes were correct. Right? So here, at the very least, sometimes we're seeing B's and L's, right? Now, what am I seeing on the scope? Yeah, it's like something like this. Something like this. Are you just looking at a waveform and counting those bits? Yeah. Yeah. I sure am. So this explains why I'm seeing the B sometimes, right? I'm seeing this in here. Then what we expect to see is from left to right or right to left. I'm looking left to right. But either way, I feel like I'm not seeing start bits. Right, so what's an L again? Capital L is this thing. Right, so that kind of makes sense with my understanding of the format, right? Here comes the B, or something. B is 0, 1, 1, 0, and this is, can we make sure that both of these are, shown with their prefixes? So say we see like a B in here, right? Then like, where are the stop bits? Like, we should always be seeing, I guess, like, left is older than right. Oh, true, huh? That's a pretty good point. Left is older than right. Let's go again, right to left. So I think it's like 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 1. Yeah, this is the pattern. Now we're going older to newer. Or, sorry. No, wait. Left to right was right. We want oldest to newest. Assuming that we're sending in sequence. No, I was right before. 1, 0, 0, 0, 1, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1. Do we want 8 and 1 or what? I popped in late. Yeah, I think that's what we want. So this has, like, one of these ones has to be stop bit. Can we? I would love to wait for a short period of time between these guys. Just because it's hard for me to interpret what I'm seeing. Okay, so with that, here's what I'm seeing on the scope. Can you guys see that shit? Right? So that kind of makes sense. That's a lot of highs, followed by what looks to be 0, 0, 1, 0, 0, 0, 1. Something like this. I think? It's hard to tell. Can I continue here? I just want to like catch this at the right time. Okay. Cool. You see that shit? So it's kind of hard to tell what like the clock rate is on that thing. But if we assume, what is my trigger? I'm just hitting pause like a dumbass. If we assume that like it could be 0, 0, 0, 1, 1. So like, here's my confusion. It's going right to left and missing the last 0. Maybe? Oh yeah, okay. So we want the first bit. So we're idle on the right side. On the far right, we're idle. Then we come in and we drop. Okay. I'm going to draw approximately what I'm seeing. Obviously, this is not going to be perfectly accurate, but it's something along the lines of like this. Right? So here we are expecting to see, this would be start bit. Then we have a bunch of zeros, then some amount of ones, then a bunch of zeros. We have no parity bit, supposedly. And so then this would be stop here, right? So or this ends in a 1 and then stop bits here. That's another option, right? So no matter what, though, that seems whack, right? Because we know that if we're sending the letter B, we should be bookended by zeros, right? And so it's pretty fucking clear that we're missing something. What about an L? And that would also maybe explain why when we send one character at a time here, he doesn't see anything. You know? That kind of explains that. Okay, so then my suspicion here is it possible that we're setting the line control wrong and he's not sending 8 bits? Like, we think that we said this 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. 1, 2. I think I might have just been off by 1 here. I think I might have had 6 bits of data instead of 8. Ah! This is what I get for taking shortcuts. Oh, we should have made a struct and counted them out and set the values correctly. God fucking damn it. Fuck me, fuck. But that's pretty hype. Technically off by 0. Yeah, okay. Well, we'll fucking take it. We'll take it. Let's go. That's pretty sick. I mean, it's frustrating. This is so fucking classic. I don't know, like people who haven't worked embedded very like this type of bug. I've done this type of mistake so many fucking times in my life. And it's just like I'm a fucking dumb idiot. I get it. So this happens every fucking time you write register files. Yeah, it is what it is. I should have been more careful. But we got there. So it's always worth take your time and build a good API. Yeah, I was like, there's no way I'm gonna get this one wrong. It felt so easy and so simple and so obvious. It felt like we had it. It's just like you set the bits 0B11, right? It just felt right, but I deserved it. All right. Well, it is what it is. Thanks for watching, guys. We're gonna call it there. It would have been nice to get a little farther, but we got real stuck on that bad boy. So we'll be back tomorrow. I don't know what we'll do. I don't know. I have to decide. Probably from getting from here to printf is not that hard. But if we wanted to do interrupts in DMA, that might be a little bit harder. So maybe we'll do that. We can, yeah. So that's probably we'll probably come back tomorrow and try to play with interrupts. And from interrupts, maybe we'll move into DMA. Not sure. But this is okay progress for today. I'm not gonna say good progress. I'll say okay. So thanks for watching. If you like what we saw, we stream most days at around 12 o'clock or 12:30 Pacific time to 4 o'clock Pacific time. It is 4:30 now or 4:40 now. So you should expect to see us online from 4 and a bit hours ago to half an hour ago ish. If you want to keep up with the projects, but you're only watching, you can't watch live every day. There's a YouTube link in the Twitch description where we put up most feature development ends up there. There's also kind of background information, reading, testing, side quests that aren't really important to the overall narrative, things that aren't really necessarily like YouTube thumbnailable and titleable. Those things you have to catch live, which are typically at the beginning half of the stream, or you can Subscribe on Patreon, Twitch, or join on YouTube to get access to like the remaining segments of the VODs. Please consider supporting on one of those platforms or GitHub. This content will end someday, and that day is kind of marked by a dollar amount in my bank account. And so every dollar that we make doing this extends the lifetime of the content by some amount. So if you want it to keep going, please consider. But no worries if not. I think that's all we have to say. YouTube, peace out, and Twitch, let's find someone to raid.